This is Food Chemistry Unit 2, Chapter 7, Water, the Universal Solvent. Water. It is a nutrient. Nutrients are food components necessary for life. There are 6 essential nutrients: carbohydrates, lipids, proteins, vitamins, minerals, and water. Water is a main component in food. It influences texture, appearance, and taste. It transports nutrients in the body and is a common liquid for cooking. Properties of water. There are covalent bonds holding the 2 hydrogen and 1 oxygen atoms together, so they're sharing electrons. Hydrogen bonds are a strong force within water, and it allows sugars in jelly, jam, syrup, and molasses to stay distributed. Surface tension is a force between molecules at the outside edge of a substance, and it forms a curve or meniscus on surfaces like this graduated cylinder, or you can check out how this lizard uses this concept. It's an adhesive quality. The higher melting and boiling points of water are due to surface tension. The boiling point of water, 100 degrees Celsius, right, is affected by atmospheric pressure, and this affects cooking times. The higher the elevation, the lower the boiling point, since there is less pressure. This means it takes foods longer to cook. So watch the difference here. We're at sea level, or 1 atm, as I create this video. So that's 100 degrees Celsius for our boiling point of water. But if you travel to Mount McKinley in Alaska, where the elevation is 20,320 feet above sea level, that's pretty high up, that boiling point of water drops to 78 degrees Celsius. Now, if you head in the other direction, to the Dead Sea, which is on the border between Israel and Jordan, that's 1,286 feet below sea level, the boiling point of water would increase to 101 degrees Celsius. Okay, so the pressure changes the boiling point. And yes, there are high altitude instructions often on packages, and it's also why the pressure cooker was created, right? Pressure cookers have steam that's released inside the cooker, and this raises the pressure. If the pressure is increased, the water requires a higher temperature to boil. Food cooks faster because of the higher temperature. Impurities in water. Hot tap water may contain more impurities than cold tap water. Heat causes things like calcium and iron deposits on pipes and water heaters to dissolve in the water. These impurities may produce unpleasant flavors in foods. So foods need to be prepared with cold tap water or filtered water. Functions of water in food preparation. It's a heat medium. When water is heated, energy is transferred to the food. Adding food pieces to water does not affect the boiling point. Some foods need a rapid boil, like pasta. This helps keep the noodles from sticking. Some foods need a gentle boil, like potatoes. This is for a more even cook. There's less breakage of the potatoes if they bump into each other when cooking. It's a common solvent. Liquids dissolve in water, like vinegar for pickling or dressings. Solids dissolve in water, like sugar, salt, and flavor compounds from coffee or tea. Water is a common solvent. Gases can dissolve in water, like carbon dioxide in beverages. Now, how this all came about was thanks to this English chemist, Joseph Priestley, in 1772. He dissolved carbon dioxide in water under pressure. He was trying to imitate this bubbling of water that he often saw in mineral springs. So the first artificial mineral water was made from adding acid to sodium salts. That's where the term soda from the sodium salts came from. You're welcome. Now, flavors were later added, and I just blocked this to get you to think, do you know what the first sodas were, or even the first flavors were? So when I talk about this in class, I give you a chance to guess, so you can guess now or not. It's totally up to you if you're watching this. Lemon was the first flavor around 1820, and then we have ginger ale and root beer. So these are your oldest flavors and sodas. It was followed by cola. By the 1850s, soft drink companies had been established, and the word soft is coming from the fact that there is no alcohol. These were soft drinks. So of the popular cola brands, cola now, any guess which was first, second, third? Wait for it, wait for it. All right, so ginger ale, first, right? But yep, Dr. Pepper, older than Coca-Cola. I believe I have the year, yeah. So this is 1885. It actually says it on the label. This is the first like commercial soda, right? And then Coke was followed very quickly in 1886. But that's right, best soda. All right, let's talk about the water content in foods. This should make sense, right? The drier the food, the less water. So fruits can have up to 70% water. Bread's about 36%, because you can slice it, right? And then popcorn about 4% water. It does have water in there. That's how the corn pops, right? Especially when you put it in the microwave. It's going after that little bit of water in the popcorn kernel, and then it bursts open. Water becomes part of the structure of food in three ways. You can have free water, which is easily separated from the food tissues, like juice from fruits. Bound water is tied to the structure of large molecules, like the water in a cactus, right? And then you have what's called a hydrate. This is a chemical compound loosely bound to water, and water is actually part of the formula. So here's a caffeine hydrate. This is caffeine, and that little dot with the H12 means it's a hydrate. So water is part of the formula. It's bonded to the compound. Make sure it's yeah, okay. All right, and of course our water supply should be safe. Physical contaminants can get into the water supply. This is garbage from beachgoers, fishing or boating. Litter carries bacteria and can break down in the water supply. Maybe you've heard of this. It's called hard water. This is where calcium and magnesium ions are dissolved in rainwater as it soaks into the soil. These combine with bicarbonates in water to form salts. They're easily removed when heated, but can coat pipes, valves, cooking equipment. This toughens the texture of fruits and vegetables during processing. If sulfur or chlorine combine with calcium and magnesium, the water is permanently hard. You can add things known as water softeners. It removes calcium and magnesium, and those are replaced with sodium.